Now we are going to discuss the last metallurgical process, that is refining of metals. Now refining of metals means purification of metals. Already the impurities, most of the unwanted impurities are removed during concentration of the ore, but still there will be minute impurities present after reduction of metal oxides. So refining method helps to remove almost all impurities from metal and make the metal pure. Now there are different refining methods. So let us discuss each one. The first one is distillation. Distillation. This refining method is useful for low boiling metals like zinc and mercury, and the impure metal is evaporated to obtain pure metal as distillate. So this method is used for the refining of mercury and zinc, which are low boiling metals. So this is distillation. Second method is liquation. In liquation, low melting metal like tin, lead, bismuth can be made to flow on a sloping surface. In this way, it is separated from higher melting impurities. So, liquation is used for refining of low melting metals like tin, lead, bismuth, etc. Now, the third refining method is electrolytic refining. In electrolytic refining, the refining is done on the basis of electrolysis. Now, we have already discussed this electrolytic refining, that is, example is electrolytic refining of copper metal. In electrolytic refining, the impure, I am giving this explanation taking copper as example. So, if you want to get pure copper, we do electrolytic refining, and in electrolytic refining, we know the impure copper is taken as anode and pure copper is taken as cathode, and the electrolyte taken is aqueous copper sulfate. Now from anode, the impure copper will get oxidized to Cu2+, which move towards the cathode, and it gets reduced and changes to copper metal and get deposited at cathode. So we get pure copper at cathode. And we know the impurities present, there is mainly selenium, tellurium, gold, then silver. These impurities will be remaining at the bottom of the electrolytic vessel, and these impurities are called anode mud. So this is the principle of electrolytic refining. Now zinc can also be refined in this manner, that is electrolytic refining method. Now the fourth refining method is zone refining. Now this is the zone refining method diagram, and the principle of zone refining method is, it is based on the principle that impurities are more soluble in the melt than in solid state of the metal. That is, you can see how it is done. Here you can see a mobile heater. Now this method, zone refining method, is mainly used for the purification of semiconductors like germanium, silicon, boron, gallium, indium, etc. So how this is done? Here a mobile heater is allowed to move on the metal rod. Suppose this is given as impure germanium rod, and a heater is allowed to move on this metal rod, and in the same direction it is moved always. Now as the heater moves, you can see the principle is the impurities are more soluble in the melt. When you move the heater, the impurities will be soluble in the molten state. These impurities will also be moving along with the heater, and the pure metal will be crystallizing out. So this process continued or repeated many times, and at one end of the road we get all the impurities deposited and it is cut off, and the pure metal is obtained. So this is zone refining method. In zone refining method, the principle is the impurities are more soluble in the melt than in solid state, and this is used for the refining of semiconductors like germanium, silicon, arsenic, germanium, silicon, boron, gallium and thallium. Now the next method is vapor phase refining method. Now in vapor phase refining method, the principle involved is the metal is converted into a volatile compound, and then the volatile compound is decomposed to give pure metal. So there are two requirements for this vapor phase refining. The first requirement is that the metal should form a volatile compound with the available reagent, and second requirement is that the volatile compound should be easily decomposable so that the recovery of the metal is easy. Now there are two examples for vapor phase refining. First is Mond process for refining of nickel. So under vapor phase refining you have to study Mond process for refining nickel. The principle is the same as vapor phase refining, that is, the principle is the metal should form a volatile compound with the available reagent, and the volatile compound should be easily decomposable. So here this is Mond process for refining nickel, and the reagent used here is carbon monoxide. So in this Mond process, the nickel is first heated in a stream of carbon monoxide, and nickel forms a volatile compound with carbon monoxide, that is nickel tetracarbonyl nickel. Now the equation is nickel plus 4CO at 330 to 350 Kelvin low temperature, we get tetracarbonyl nickel, NiCO 4 times, which is a volatile compound. Now when you heat tetracarbonyl nickel to a higher temperature, it decomposes easily and we get pure nickel. So the next equation is NiCO 4 times. On heating to higher temperature 450 to 470 Kelvin, we get pure nickel plus carbon monoxide is released. So this is an example for vapor phase refining technique. There is Mond process for refining of nickel, and here the nickel first forms a volatile complex with carbon monoxide, and in the second step the volatile complex is decomposed at higher temperature to get pure nickel. Now the next example is Van Erkel method. Second example for vapor phase refining is Van Erkel method for refining of zirconium and titanium. So Van Erkel method is used for refining of zirconium and titanium. So we need a suitable reagent with which the zirconium or titanium can form a complex, and here the reagent used is iodine. So in Van Erkel method, the crude metal, that is zirconium or titanium, is heated in an evacuated vessel with iodine. It forms a metal iodide, that is zirconium tetraiodide or titanium tetraiodide. So the equation will be, with zirconium I will write the equation, zirconium plus iodine, you get zirconium tetraiodide. Now The second step is decomposition of zirconium tetraiodide. But here this metal iodide is decomposed on a tungsten filament, electrically heated to about 1800 Kelvin, and the pure metal is deposited on the filament. So next step is the decomposition of zirconium tetraiodide. You get zirconium plus 2I2, and this zirconium is pure zirconium, free from all impurities. So this is the Van Erkel method for the refining of zirconium and titanium. So suppose it is with titanium, you get the same thing. Titanium will combine with the iodine to form TiI4. TiI4 is then decomposed on tungsten filament. We get titanium plus iodine. So this is Van Erkel method for the refining of zirconium and titanium. Now the last refining method is chromatography. That is number 6. Chromatographic method. Now, chromatography is based on the principle of adsorption. Adsorption. Now, in this method, the principle is based on the fact that different components of a mixture are adsorbed differently on an adsorbent. Now, there are various chromatographic techniques like gas chromatography, paper chromatography, column chromatography, etc. Now, in any chromatographic technique, we have two phases. One is mobile phase and the other is stationary phase. Stationary phase. Now, the mobile phase is usually a gas or a liquid, and the stationary phase is immobile, and in column chromatography we use aluminum oxide as the stationary phase, or in paper chromatography paper will act as the stationary phase. Now the mobile phase and stationary phase are chosen in such a way that the components of the sample have different solubilities in the two phases. Now what is done is the sample, this is the diagram of a column chromatographic technique, and here we have aluminum oxide as the stationary phase, and mobile phase can be liquid or a gas, and the sample that is to be refined is dissolved in this mobile phase and it is pushed into the stationary phase. Now the mixture is put in liquid or gaseous medium and it is moved through the stationary phase, which acts as the adsorbent, and different components present in the mixture will be adsorbed at different levels in the column, and later the adsorbed components are removed, or we use the word elute. The different components are eluted by using suitable solvents, and the solvents are known as eluents. And this chromatographic technique is mainly useful for purification of elements which are available in minute quantities, and the impurities are not very different in chemical properties from the element to be purified. So this is chromatographic technique which works on the principle of adsorption, and this is an example for column chromatography. And the principle of chromatographic technique is different components get adsorbed at different rates on the adsorbent. So with this we complete all 5 refining techniques. So the 5 refining techniques are: first is distillation, second liquation, third is electrolytic refining, fourth is zone refining, 5 is vapor phase refining, and under vapor phase refining we have Mohn process for refining of nickel, and Van Erkel method for the refining of zirconium and titanium, and the last process is chromatographic method. So thank you.